Hello everybody, my name is Andy Sunderman. I am the CTO of Fairwinds. We are a Kubernetes company. We've been doing Kubernetes managed services for about 6 years. We've been doing Kubernetes software as a service for about 4. And that entire time we've been authors and maintainers of open source around Kubernetes. And so I'm here today to talk to you about a specific project called Goldilocks. And Goldilocks is a tool to help you set your resource requests and limits. So, like I said, we've been managing clusters for folks for many years now, hundreds of clusters across several different cloud providers. And one of the things that we always tell our clients, and it's one of the things that we start with, is you need to set your resource requests and limits, because everything else in Kubernetes is really based on that. The reliability of your applications, the ability to scale up, not spending too much money is based on that. Like, everything is tied to resource requests and limits. It's kind of one of the more fundamental things that you can do. And so we would tell our customers, hey, please set your resource requests and limits. And then they would ask us the very reasonable question, what do I set them to? And that's where we said, okay, back in the day, we would go look at a dashboard, a metrics dashboard. We'd look at the historical usage and, maybe draw some lines and say, set it here, like maybe here if, you're worried about it, set it a little higher. And it was a really manual process. It's not really self-service. It's a lot of effort for us. And so there's got to be a better way. Like, we've got to be able to look at existing usage and recommend something. So we went looking for a recommendation engine. And we found one. It's called the Vertical Pod Autoscaler. And you may be familiar with the Vertical Pod Autoscaler. So in that it can set your resource request limits for you, but it does this by recommending them first. It has to know what to set them to. And so there's a recommendation engine built into the Vertical Pod Autoscaler. So we said, well, great, let's use that instead of reinventing the wheel here. And so what you do is you create a Vertical Pod Autoscaler for each and every object or every deployment or daemon set in your cluster. And then you can go look at, what it's recommending. Well, Goldilocks does that for you. So it's two pieces. It's a controller and a dashboard. The controller creates Vertical Pod Autoscaler objects for your workloads, and the dashboard summarizes all that data and shows it to you in a nice, easy to consume way. So that's what Goldilocks is for. So let's just go ahead and kick straight into the demo. I have here just an open terminal, and I'm going to start with a brand new clean cluster. So we are going to use Kind, which is Kubernetes in Docker. And I'm going to use a 1.23 cluster. The default now is 1.25, but I'm just a little more comfortable. This demo definitely works in 23. It shouldn't have any issues with 25, but who knows? So I'm going to fire up a Kubernetes in Docker cluster here. And the first thing I'm going to do is install all of the prerequisites. So this is probably the trickiest part of getting Goldilocks running, is you need to install a few different things. So first of all, most likely you have this in a lot of your clusters already. It's the metrics server. And so metrics server is what allows us to do things like kubectl top pods and see the usage, the resource usage of those pods. So that is the first prerequisite. We're going to install that here in a second once our control plane comes up. And then the second one is the Vertical Pod Autoscaler, which I just talked about. We need to get that installed. So I will do that here in just a moment. We have Helm charts to do all of this for us. So I've got some Helm commands I'm going to put in. So this one installs the metrics server. We're going to put it in its own namespace. I'm going to set the kubelet in secure TLS flag so that it works in Kind. And so that gets our metrics server installed. In a few seconds, we'll test and make sure we have metrics flowing into the cluster. The next thing I'm going to do is install the Vertical Pod Autoscaler. Fairwinds has provided a chart for that. There wasn't a stable upstream one at the time when we created this, so we have this Fairwinds stable VPA chart. By default, we're only going to install 2 parts of the Vertical Pod Autoscaler. There are 3. And we really only need 1, so that was probably a little confusing, but we really just need the recommender so that we get these VPA recommendations. So if we look in the VPA namespace now, we should see a recommender coming up. That is the most important thing. And then the other thing is that we have the CRD for the vertical pod autoscalers installed. So there's that. And then we need to be able to top pods so that we have some sort of existing CPU and memory. So what the vertical pod autoscaler is going to do is going to watch pods. It's going to see how much resources they're using, and it's going to recommend what you should set it to. It's relatively straightforward, that's all it does. So the last thing we're going to install, finally, we get to the important bit. We're going to install Goldilocks. And again, helm install Goldilocks in the Goldilocks namespace. Create that namespace. It comes from the Fairwinds stable repository, and it is the Goldilocks chart. Relatively straightforward. The version that we're installing today is v4.5.0. That is important because we have just released some cost features that I will talk about here in a moment. So there's two parts to Goldilocks. There is the controller. The controller is what watches for workloads and labels on namespaces and creates vertical pod autoscalers for those objects. And then there's the dashboard, and that's the piece that lets us see what's going on inside of our cluster. So let's wait for those pods to get running. The controller is running now, and hopefully we'll have a dashboard here in just a second. And I'm going to pop open a new tab here, and I'm going to do a port forward. So we're going to port forward in the Goldilocks namespace to the service Goldilocks dashboard. And it's going to run on port 80, and I'm going to forward that to 8080 locally. Assuming our pods get running here, we're good to go. So that port forward will sit there and run in the background. And I'm going to navigate to localhost 8080 in my browser. And so I'm going to close off that terminal here for a second so we can see this screen. And we're going to see here that we have nothing. There are no namespaces listed here. It says no namespaces are labeled for use by Goldilocks. Try labeling one. So it's telling us exactly what we needed to do. So Goldilocks by default doesn't create any vertical pod autoscalers until we tell it to. We tell it to do that by labeling a namespace with the goldilocks.fairwinds.com/enabled label. So I'm going to go ahead and do that. I'm going to label the namespace cube system. Why not? Goldilocks.fairwinds.com/enabled equals true. All right. Oh, I didn't show that in my terminal, but we can go back and see that here. It's just a simple kubectl label command, and it says it was labeled. And now, if we do a kubectl get VPA in the cube system namespace, we're going to see we have 3 vertical pod autoscaler objects. Important thing to note here, these are in the mode called off. That means they're not going to try to actually update any CPU requests, memory requests, or limits. It's just going to sit there and watch and provide recommendations. And so hopefully in a few seconds, there it is, it's going to fill out those recommendations. So we have a CPU recommendation, a memory recommendation, and it provided has been switched to true. So recommendations have been provided. So at this point, the dashboard should start to populate with data. So I'm going to close my terminal again. We're going to go over here and we're going to refresh this page. And we see that we have the cube system namespace. So I'm going to go ahead and click into that, and we are going to see right off the bat our recommendations. So we have these recommendations for multiple QoS levels for guaranteed and burstable QoS. We're going to see where we are in relation to those recommendations. So here we don't have a CPU limit set. Right now the recommendation engine is recommending 15 millicores because that is the minimum that VPA recommends, and that's configurable within the VPA itself. And so we can pop open this YAML here. We can copy that out if we want to just paste it straight into our infrastructure as code. And really this is the meat of what Goldilocks does. So Goldilocks looks at what's running in the cluster, provides recommendations, tells you where you are with those recommendations. Now there's a little bit more to it than that, and we can continue to go on. But at the end of the day, Goldilocks is a relatively straightforward tool. You don't need to do a lot with it. So important note obviously, this is only showing us current usage. This is an example cluster. There's no load running against it. So we recommend you run this against, a load test cluster or somewhere where you're actually running load against it, or even running in production, because it's non-disruptive. You're just going to create vertical pod autoscaler objects, and you're going to observe those. So, in a staging environment, it's great if you're running load tests, because then you can make changes before it makes it out to prod, but prod just as good. So we see here also that we're able to pick up daemon sets as well as deployments. That includes basically anything that can create a pod. I have learned that jobs and cron jobs don't work extremely well, but it is something that we are considering in the future. And then we see down here at the very bottom, we give you a handy little glossary that explains what quality of service is. So if you're not familiar with quality of service, it's just a class that gets assigned to your workload based on how you configure your memory requests and limits and your CPU requests and limits. So we have the guaranteed QoS, which means that we've set them exactly the same. And we have burstable, which means we're requesting a certain amount, but we're allowed to burst up into a larger amount. The important thing to note there is that requests are used for scheduling and scaling. So keep those in mind. So we can go back to the list of namespaces here. Now we've only labeled the one namespace. You may be saying to me like, hey, Andy, I've got like 200 namespaces in my cluster. I'm not going to go label every one of those individually. And that's totally fair. If you want to run it across your entire cluster, we can totally do that. So I'm going to swap back to my terminal here, and we are going to reinstall Goldilocks, but we're going to add a couple of flags. So let's get that Helm upgrade install command that we have here. And I am going to add two flags, one for the controller and one for the dashboard. And this is what is going to we're going to set the on by default flag on both the dashboard and the controller. I'm going to set that to true. So I'm going to go ahead and reinstall Goldilocks with those flags enabled. And so that's going to automatically run it in every namespace unless I label it with the Goldilocks enabled false label. So the other thing I'm going to do here, just to kind of show how we've inverted the use of that label, is I'm going to label the cube system namespace with the goldilocks.fairwinds.com/enabled label set to false. So I'm going to do a -- overwrite there, and that's going to reset it. So let's take a look and make sure we have our pods in the Goldilocks namespace. We're still restarting, so we're going to give that just a second to restart. And once we have new pods, we'll go take a look at that dashboard again. While we're waiting for those to restart, another important note is to think about your usage of the horizontal pod autoscaler in this scenario when you're using Goldilocks. So there's two important things. One, the vertical pod autoscaler and the horizontal pod autoscaler don't play nicely together when you're using HPAs with CPU or memory metrics. This is because the vertical pod autoscaler and the HPA will kind of fight each other over those metrics. So that's one important thing to note. The second is that Goldilocks and the horizontal pod autoscaler, when you're scaling based on CPU or memory, are not going to play nicely together either. So if we have our horizontal pod autoscaler set to 80% CPU usage, Goldilocks is always going to see, the vertical pod autoscaler recommendation is always going to see that we're at, 80% of our CPU requests and suggest that we lower the amount because the horizontal pod autoscaler is doing its job. So if you want to use Goldilocks in that scenario and you want to understand your actual usage, I recommend, pinning your HPA to a specific count. So not letting it scale up and down essentially, and seeing the actual usage of the pods. The other thing that I highly recommend and suggest to a lot of folks is not scaling on CPU and memory. So if we can scale on something like latency or request count or something like that, or queue depth if we're processing a queue, I think those are far more effective ways to horizontally scale our pods that will play perfectly nice with Goldilocks and allow us to fine-tune our resource requests and limits a little more carefully. So We have our new pods here, so I'm going to go back to our dashboard. I'm going to close this terminal, and we'll go back to our dashboard and refresh this page, and we'll see that we have a bunch of namespaces listed here. That's all the namespaces in the cluster, but we won't have the kube system namespace. And I just realized I need to go fix my port forward because I restarted those pods. So we'll get that port forward restarted, and we'll go back to the namespace list. So we have all the namespaces in the cluster except for the kube system namespace, because that's the one that we labeled with goldilocks.fairwinds.com/enabled equals false. So you can see how that label behaves when you set the on by default flag. So let's go take a peek at, for example, the Goldilocks namespace itself. Why not? Go a little meta here and click into that, and we can see our dashboard. We've got our deployment for the controller. We've got our deployment for the dashboard, and we've already seen all of this as well. The only other thing to show here is that we have this detail all namespaces button. That will go ahead and show you this view with all of the details for every namespace that you have available. So, we'll scroll through here and you can see we have the VPA namespace and the Goldilocks namespace, and all the namespaces are here. So that's the only other thing on the dashboard. And then we can, filter down from here if we want to just filter down to Goldilocks. So that is the on by default flag and how we set that. So we've gone through installing Goldilocks, we've gone through enabling it in namespaces, we've installed the VPA and the metric server as prerequisites. We've really covered in a relatively short amount of time all of the major features of Goldilocks. So the next question you may be asking is, what about historical data? How much historical data does the vertical pod autoscaler take into account when doing this? Because maybe I have a workload that only runs heavy on Mondays, for example, right? And so I want at least a week's worth of data, and probably more, to get an accurate representation of what my historical usage is. So vertical pod autoscaler has a solution to this. It's enabling Prometheus in the vertical pod autoscaler as the storage method. So if we go look in the autoscaler repo, so we go to the Kubernetes autoscaler repo, and we go to we go to the vertical pod autoscaler first, and we go into package recommender, because that's the piece that we're utilizing. Here's the recommendation engine, and we go into the main.go for it. What we're going to see is a bunch of flags that allow us to configure the vertical pod autoscaler. So if you want to tweak how you get your recommendations, how you're doing your recommendations, this is the way to do it. So they give us the option to point at a Prometheus address. So point there, and then we can flip this storage mode. So by default, it uses this checkpoint, which is another CRD in the cluster, to keep track of usage over time. But we can swap that to Prometheus, and then we can control history length, history resolution, and then some tweaks around how we find stuff in Prometheus, so the different labels and things that we search for. So definitely probably the best thing to do for the most accurate recommendations is to use Prometheus. So I'm going to go ahead and show how we enable that. If we go back to our terminal, we're going to reinstall the vertical pod autoscaler, but we're going to do it with a couple of additional flags. But first, actually, I forgot, we probably want to install Prometheus. So this is going to install Prometheus using the Kube Prometheus stack chart from the Prometheus community repository. And I've just set a couple things to disable Alert Manager and disable Grafana, because I don't need those here. I just need a Prometheus instance running for the vertical pod autoscaler to query metrics. So we're going to go ahead and run that, and we'll see get pods in the Prometheus namespace. We're going to see a few different pods come up as part of this. And it takes just a minute to go. But we're going to see the Prometheus operator get installed. We're going to have some CRDs added. And then we're also going to have an actual Prometheus instance. So an actual Prometheus running here. So getting some jobs running. This one does take a minute or two to get going. And we can take a look at our CRDs in the cluster and see that we've got Prometheus and service monitors and alert managers and all that good stuff coming in. And here we go. Now we've got a node exporter that's going to get our node metrics and send them to Prometheus. We've got the operator. We've got kube state metrics, which provides information about the state. And now we have our actual Prometheus instance running here. So let's take a look at the services in the Prometheus namespace. And what we're going to see here is we've got a kube Prometheus stack Prometheus with port 9090. That's what we want to point our vertical pod autoscaler to. So we've got this service in the Prometheus namespace. And so what we're going to do is we're going to reinstall that vertical pod autoscaler. So I'm going to install VPA. Oh, and I have it here already. We have, we're going to put that in the VPA namespace again, but we're going to set the recommender.extrahours.prometheus address to the HTTP address of that service on port 9090. So the kube Prometheus stack, Prometheus.Prometheus:9090. And we're going to set that storage flag to Prometheus as well. So we'll go ahead and reinstall the vertical pod autoscaler there. And we can take a look and watch those pods come back up as we restart them, or at least the recommender will restart. And we can take a look at the logs, and hopefully what we see is the vertical pod autoscaler reaching out to Prometheus to pull the metrics for our various workloads. And for that, oh, I need to spell recommend correctly. There we go. All right, so now we see historical memory usage, query used, container memory working set bytes. You can see all the queries that it's running against Prometheus to get the various recommendations. So we can say get VPA-A and see our recommendations are changing here. So that's great news. And now we should be getting more accurate data in this cluster over time. So definitely recommend doing that, especially if you have an existing Prometheus already. Just point the vertical pod autoscaler at that, and you'll get much cleaner recommendations. So that is how we get historical data. Beyond that, I think the last feature to show is one that you've already seen in the dashboard over the last couple of iterations that I've shown you, but I didn't talk about it at all, and that's our cost settings. So I'm actually going to do this in a new, well, actually we're going to go to the dashboard again, and we're going to take a look at the cost settings here. So we've recently enabled the ability to get cost information into Goldilocks, because while Goldilocks isn't strictly a cost management tool, it allows you to set resource requests and limits and help you fine-tune those. And by fine-tuning those, we're going to change the cost of our cluster. If we use more resources, it's going to cost more. If we use less, it's going to cost less. And so using these recommendations and correlating them to cost can be a very interesting exercise and help us identify places where we have the biggest discrepancies and where we can save some money. We all love saving money, right? So once you run the newest version of Goldilocks, v4.5.0, you're going to go in and see that there's a place where you can put in your email address, and we'll send you an API token. You put that in, and that's going to go hit our API and pull in this cost data for the different cloud providers. So we can set GCP or AWS. If you set it to other, you can just put in dollars per gigabyte hour or per CPU hour for memory and CPU. But I'm going to go ahead and say AWS, and let's say I'm running on, I don't know, let's pick something a little more expensive, like an M4 extra, M3 extra large. What's M3? M4 extra large. There we go. So that's automatically going to say how much a gigabyte of RAM costs me per hour and how much a CPU costs me per hour. And we can correlate that back to our workloads. So we see here that right now the Goldilocks controller is costing us 0.05 cents an hour. So not a lot. And we're actually recommending that we increase our CPU requests and limits because we've been using a lot. And so we're going to bump that up a little bit. So we're going to see our cost go up just slightly in that case. But if we find another workload maybe that is over provisioned here, where we're suggesting dropping our CPU requests and limits, we can see our cost go down here. And we can still see our current cost here. So nice feature that we've given you, so you don't have to do the math yourself. You don't have to punch in CPU hours and go try and look at your bill and all that good stuff. So keep an eye out for that and give it a shot. File any issues that you have with it, please, in the github.com/fairwindsops/Goldilocks repository. And so yeah, just to recap, we have installed Goldilocks. We've installed all the prerequisites for Goldilocks, so the metric server and the vertical pod autoscaler. We took a look at the Goldilocks dashboard and what information that provides us. We've connected the vertical pod autoscaler to Prometheus to get more historical data. We've seen all the flags that we can use to change how the vertical pod autoscaler recommends things and finds its metrics. We've looked at how you can automatically run Goldilocks across your entire cluster or just limit it to specific namespaces that you label. We've talked about how Goldilocks interacts with the horizontal pod autoscaler, and then we've shown the brand new cost settings, cost information that you can see in Goldilocks when you run it. So I hope you all enjoyed learning about Goldilocks today, and I hope that you'll give it a shot and give us any feedback that you have on GitHub or reach out via the Kubernetes Slack. Happy to chat there. We also have a Fairwinds community Slack if you'd like to pop in and talk about Goldilocks there. There's a link in our documentation at goldilocks.docs.fairwinds.com under Join the Open Source Community. So please come check out our Slack, say hi, and fill out any issues, or definitely check out any open features that you might like to work on in Goldilocks, especially this time of year. It's Hacktoberfest. So thank you all for listening, and I hope you have a great rest of your day. Thanks.